for attending. Thank you for being here at Devoxx. We are really proud of being at one more edition of Devoxx, and congratulations for all the community effort for doing Devoxx Morocco. This session will talk about adding ears, eyes, and mouth to your IoT project. That means communication, human interface, and lots of protocols behind that. So we'll talk about that. Vini and I, our Twitter handles are there. So at @Sanger and vsanger. We are founders of Global Code and also our own conference called the Developers Conference, which will be 10 years in 2016. We are part of the board of Soul Java, and we also run the J Duchess chapter in Brazil, so trying to get more women involved in technology. This year we just launched our second hardware product, IoT Surfboard. We'll be talking a little bit about that. We both are Java champions. We got the Duke Choice Award and got the title as Java 1 Rockstar Speakers in 2011. So I must say thank you to this great program called Java Champions. So this this program is kept by the community. So the Java Champions takes care about accepting, approving, inviting new people to be Java Champions. The program is maintained by Oracle, which supports that and helps these Java Champions to go around the world and share knowledge. So if you're not aware about Java Champion, you should really take a look on this program, talk to the Java user group, and understand how your community fits to that program. So thank you very much, Oracle and Java Champions program, for helping us to be here. So the Internet of Things is a great possibility to put together your passion, your problem, your life, and the technology. So here there's a short list of some projects we have been working with. So horse telemetry, just to learn more about accelerometer and the herd and everything from the horse, racing horses. We also worked on a smart boat project that was a big passion. So it started with a broken automatic pilot and end up taking pictures, censoring gas, censoring water pumps, and lots of other things. We also put another passion together with the Internet of Things with this biking. So we got near a startup that wants to do this smart helmet, putting together picture, GPS, connectivity through your Android phone, tethering or anything. So it was this helmet for bike hiding. Also do-it-yourself satellite for 5th grade kids, Minecraft robot with bidirectional communication to the game, and also a smart building project with a framework we developed called J-Home. So that are some interesting projects. Just to let we know, we are going to talk a brief basic concepts. If you already did anything with Arduino or Raspberry Pi or Intel Edison, can you just stand your hand? Okay, thank you. Let's go for the basics.
So, good morning everybody. I am Vinicius Sanger. In IoT space, if you look in the abstract architecture, we still have the layers like in the past that we had client-server approach, and so we had 3-tier approach, 4-tier approach, N-tier approach. So in the same idea, we have almost 4 layers or more for IoT. We have the edge device, which will be the very low energy, low power consumption, and low capabilities device to grab the data from the sensors. The edge device, mostly they are not smart, or they cannot be very smart. And we have the gateway to deal with the edge devices and transmit the data to the cloud. And so from the gateway we have the cloud and all the server side, and so we have the consumers. So the edge device, many times we will be using microcontrollers without any kind of operational system, or we are going to use a minimum operational system, or we are going to use a real-time operational system depending on the type of the project and the process that you need there. You will have sensors and controlling motors, controlling lamps, controlling infrared devices, and edge devices may not support TCP/IP. They can be so small that they just communicate using a specific protocol and physical communication layer like radio frequency, ZigBees. We have Bluetooth communication, which is not TCP/IP. And many edge devices can have real-time support. Like if you have a board that you don't have any kind of operational system, if you don't have the operational system, it's up to you how your code will answer and how much it will delay. You can have all the control around the delays in your edge device, and this is what we call as real-time support. Being a real-time device doesn't mean that it's fast or the performance is great. Real-time support means that you don't allow delays. And so the next layer would be the gateway. The gateway, we are going to use a regular operational system. Mostly we use Linux for doing that. We are going to use microprocessor or system on chip, which is a complete computer inside just one chip. So low energy is not very low energy like the edge device, and may support something other thing than TCP/IP. The gateway is very responsible for translating like the ZigBee to TCP/IP, the infrared to TCP/IP, the Bluetooth to TCP/IP. The very common consumer product that use edge device and gateway are the smartwatches. Smartwatches, they are Bluetooth because Wi-Fi would be too much for a smartwatch. And for your smartwatch, for your Bluetooth smartwatch to communicate with the gateway, it will use the Bluetooth, and the gateway will be your cell phone. So your cell phone is a very popular, the most popular internet gateway is the smartphones. And the gateway will have many responsibilities different from the edge device. The edge device, they are limited to control some stuff and to read some sensors and to do something else, but not too much. And the gateway will be providing like integration layer, security layer, persistence layer, and so on. And we have the cloud computing, so it's very related to the Internet of Things, the big data, transforming the big data in knowledge, transforming the pure data in information, and so transforming the information and knowledge, and transforming the knowledge in intelligence. So that's the way we can predict the future, the sensors, and make the things very smart. Like if you are running with Runkeeper, if you are using Runkeeper standalone, it cannot compare your performance with your friend's performance. So once you have all the big data and all the collective data, you can bring intelligence to your device. Social network and many other things that we have in the cloud computing. And the consumers, we can have the consumers application consuming the data from the cloud or from the gateway directly using different types of protocols. Now we have more than 10 new good protocols for Internet of Things. MQTT is the senior protocol for Internet of Things. MQTT is in the market the last 15 years. So it's almost old like Java, but now it's getting more popular because of Internet of Things. We have some more advanced and redesigned protocol for the days that we are living, like AMQP, CoAP is another protocol that is very interesting for Internet of Things, but is not that popular like MQTT. I will talk more about MQTT today. I will be using a lot. You also have the human and the application protocols like REST, web services, and other APIs. But for communicating device to device, using REST would be too much energy consumption. And when we are talking about Internet of Things, every time you send a message over the network, you must take care in how much data you are spending. Like today, the people just write a REST application and they don't care about how big is the datagram. Let's extract one character from one place to make it lighter. So that's not the concept of doing web applications. We don't care about energy consumption and network consumption as we take care in the Internet of Things. And the most popular consumers for the Internet of Things are the phones and the tablets and video games, but you can have other devices. Today we bring here the Intel RealSense for emotion recognition, gesture recognition, and you have the Kinect and many devices that can interact with all this space. And so that's the idea of the 4 layers behind Internet of Things. So the edge device, we have this sample here, the IoT surfboard. We don't have TCP/IP in our IoT surfboard, and it's not a smart device. And we are using here the Zigbee. Zigbee is a wireless communication in the same frequency as Wi-Fi, but it's much more low energy consumption. And you have the concept of mashup network. One Zigbee can talk with another Zigbee that can talk with another Zigbee. With that, you can have very long distance network, like Zigbee is very used in farms to monitor, like in Brazil, we are crazy about barbecue, and many times that we are eating a very special piece of meat, I used to say, hey, take care about this meat, appreciate this meat, because this is an IoT cow. This meat was monitored since the cow just born, and they monitor all the time this special kind of meat. And Zigbee, we have another good thing around Zigbee is that Zigbee itself is a microcontroller, so you can plug direct some sensors direct to the Zigbee. You don't need Raspberry Pi or Arduino. You can use just the Zigbee module. And the only thing about Zigbee that is kind of expensive, but is a professional way to communicate and create IoT. And today we have here this board we will be showing. This is the IoT surfboard, which is based on Arduino, and also it has a Zigbee. With that, we can have much more sensors. We can have display, and we are going to power this guy just using a very simple phone charger battery. So this is the device that we are going to use as our Zigbee Edge device. The surfboard, we have many different sensors. It's a Brazilian board. It's a product that we are launching based on open source standards with many open source software behind.
And just to share something here, we see that the Java community, the open source community, and the makers community have lots of things in common. So both are, if we think about the Java community, it's essentially a makers community. Of course, we are making code, but we still making things, making projects, making, the tools we need, solving our own problems. So the IoT surfboard was our first experience with crowdfunding, and it was awesome. If you have your own project, if you have your own idea and you want to go for it, we highly recommend you to take a look, to make your business plan or your MVP, and go for it. It's really a fantastic experience of doing crowdfunding.
So the gateway will be the entrance point for the other devices that they are non-TCP/IP devices. It will convert the protocols. Like if you have infrared equipment in your house, you can just send a tweet to your gateway. The gateway will receive your tweet through the TCP/IP and the Twitter protocol, and the gateway will take care about sending the infrared sign to your infrared equipment. So that's the basic concept of a gateway. Here, what we have as a gateway is the Gemalto concept board. Is a very nice one. We are really using very hard this board called Gemalto concept board. We have here in this wood surfboard in the back, we have this board. It has a Java ME support in the silver processor here. You have here the 2G and 3G connection and also GPS. Not in this model, but you have a model with GPS. So in just one system on chip, you can have Java update over the air. You can run many applications at the same time. You can have like a sleep mode to spend less, to consume less energy, and it's a very, very nice board. This is, it's running Java ME 3.2. It's a very powerful platform, very used in the industry, in the real industry, and this is for doing real products for the industry, like many payment system and payment machines that you just pass your credit card. They are using this guy. In Brazil, all the payment machines are using this guy. So sometimes the people ask me about how is Internet of Things and security. Oh, it's good. You use your credit card and the machines, the credit card machines, they are all edge devices. Credit card system is an IoT system, but it's all about money. If you trust your credit card and that machine, you can be sure that you can have a reliable and secure project in IoT space. Just do like the banks. If you have problem with your data, you must take care about your data like the banks take care about our data.
So this is just the developer board. Of course, when we go to production, they are not using this orange board. They are just using the chip and then factoring in another way. So this is just developer board.
Yeah.
And when we went to this conference, Gemalto conference, we saw lots of layers. You can do cryptography and other stuff on top of that. So you can even go further with the security, adding physical layers to that.
Yeah, and the good thing about this board is also that it's a small gateway. It has TCP/IP, and you can have a standalone small gateway and edge device in the same guy. So this guy can store data, and make many other things. So we love to work with Gemalto boards and Gemalto guys. They are amazing engineers. It's a German company, and just work, it's amazing. And you can have bigger gateways, like a Gemalto concept board is 2 megabytes of RAM, which for me is a lot. Like I'm used to work with 2 kilobytes of RAM, so we make magic with that. So 2 megabytes is good, but it's not good to run like, I want to run an application server. I want to run a REST server here. I want to run a business intelligence. So that wouldn't be enough. So for makers and prototyping, it's very common to use Raspberry Pi. Raspberry Pi is very nice size for gateway devices. You can run Java 8 in Raspberry Pi amazing support from Oracle to make the Java to perform great into the Raspberry Pi. They really optimize in low-level instruction to make Java better for Raspberry Pi.
And for Raspberry Pi, is another thing that is important. It handles video. You can plug it on a monitor or a TV. And lots of people are using JavaFX on this case with Raspberry Pi. It works really well.
Yeah, that's true. JavaFX performs great on Raspberry Pi because Raspberry Pi, almost half of the processor is a graphical processor unit. So if you are using a headless Raspberry Pi, you are using half of the Raspberry Pi powerful.
And then, because it's not an edge device, depending on which sensors or actuators you want to use, you might end up using an Arduino together or another edge device that takes care of these real-time sensors.
And as you can see here in the image, we just have on board the Ethernet cable connection. So here we need to use a Wi-Fi dongle if we want to provide wireless connection to your Raspberry Pi. So you have the audio and the video and the Ethernet, but you don't have the Wi-Fi inside the Raspberry Pi system on chip. So the next guy for doing gateways is the Intel Edison. Intel Edison is a 3-core board. It's smaller than Raspberry Pi, and you have 2 Atoms and 1 Quark. You have 2 Atoms running Linux. The Quark is bare metal, so you can have the best of both worlds, running real-time stuff and running applications on Linux. And beyond the 3 cores, we also have Bluetooth Low Energy and Wi-Fi. And this is great to see that the size of Intel Edison is half of a credit card. So it's amazing that Intel is doing this crazy thing. And actually, Intel Edison is a 2-year-old board. Intel just announced the Intel Curie, which is a bottom size of board, and you can do wearable very easy and with low energy and everything.
Here's the same case as Gemalto. The board is bigger because it's a developer board, and when we talk that the chip is half of the size of a credit card. But something nice, they just announced the Java one this year. Azul Systems, who does the JVM, high performance JVM, including the JVM that is running inside Microsoft Azure, just announced the new Zulu for Embedded, which is a distribution based on OpenJDK that was customized and high performance for Intel Edison. So now what we have is an OpenJDK JVM that is being customized and made for embedded, which is pretty good for the embedded community in terms of license.
So I show here as edge device, we are using this ZigBee guy. We are using this IoT surfboard that could be connected to the 3G. Not today, we are not using the 3G to avoid any problem with the communication. But we have this guy that is connected through the USB cable in my computer. And we bring this guy, we did this I/O tablet. This is a wood computer. Inside this computer, I don't know if I put the picture here. Okay. Inside this computer, we have the Raspberry Pi. The Raspberry Pi here. We also have the Intel Edison here, and a battery, and we have a ZigBee module in the side. We have in this computer we have a Raspberry Pi 2, which is a quad-core. We have the Intel Edison with 3 cores. So inside this computer, I have 7 different cores, and I have Wi-Fi support, ZigBee support, and Bluetooth Low Energy support. And I have another thing that is a lighter for cigarette.
So in this case, we needed to use the Raspberry Pi because of the screen. to handle images, sound, video, and then the Intel Edison runs the connectivity. Right?
Yeah, that's true. So we use it a lot, this laptop, and it's great to build your own laptop. Now, I was waiting the last 20 years to build my own computer, and because of Internet of Things and because of single board computer, big wave of single board computers, you can start doing your own laptop, and this is working great. We are running from conference to conference, and we just power this guy and it starts working. So amazing to see that. And I'm using a screen. This screen is called chalkboard. It comes from the iPad 1 or iPad 2, and is a kind of $100 screen. It's a touch screen and very nice resolution. So it's very good to customize your own laptop. Like I can use my car, the power 12 volts from my car to give energy to this laptop. So it's much better than the power energy from laptops, which is mostly 19 volts, which is not easy to find a solid plug with 19 volts. So to resume, we have today the IoT surfboard. This guy plugged through the USB connection, plugged in my laptop. We have the IoT surfboard with the Zigbee and using the IO tablet as gateway and XB as communication, XB or Zigbee. And we have, just to show here, the IoT surfboard integrated with a concept board. We have in the menu, but we are not demo this board today. So in the edge device, we did a framework called IoT API for Arduino. Actually, it's not just for Arduino, it's for the family of microcontrollers behind Arduino called HML. And this framework helps you to integrate. And behind this framework, we have the IoT surfing protocol, which is a JSON protocol. Is a standard protocol. It's the same protocol if you are using USB, if you are using XB, 2G, 3G, or any other way to communicate. Even Bluetooth, we are supporting in our framework.
And here, just this is the most challenging for Java developers, since we do have other protocols and we deal with real-time interruptions and how to handle these sensors that are, reading very, very fast, lots of times per second. So the bigger challenge for Java developers that wants to get into IoT is exactly how to handle this data from the edge device and bring them to the gateway layer. And when we are on the gateway layer, we are already coding very familiar code for us, Java code already.
So in the gateways, we developed IoT surfing service, which is a Java microservices kernel for Internet of Things. It's an open source. We are working in this framework the last 6 years. In the beginning, we call as JHome, and so we changed for Things API for Java, and now we are calling this new framework, this new version that we refactored to have a microservice kernel. And the name is IoT Surfing Service.
And on this IoT Surfing Service, the main idea is to get all the data, pre-process that, and send the interesting information to the cloud to be really processed or applying big data or any other concept. So that's an important communication layer.
For the code in the edge device, this is a C code, very simple to understand. So here I'm saying in my edge device that I have a red LED plugged in the port number 10, the green, the blue. I have a relay plugged in the digital port number 4, a speaker in the digital port number 16, alcohol sensor in the analog port number 0. So what I'm doing here, I am declaring the stuff that I put in my edge device, that I connect, that I wire up in my edge devices. So with that, the edge device will be able to describe itself, and the gateway will be able to discover the edge device automatically. If you change the components in the edge device, you don't need to change your protocol, you don't need to change your gateway. So that's very nice way to code Arduino, because if you do a lot of C code in Arduino, in the end you are going to have a very anti-pattern code, like a spaghetti code. We try to avoid it in the edge device, since the Arduino code is getting more and more value to the business. And we also have here declaring a temperature and a humidity sensor. As you can see here, this is a custom sensor. It means that reading the humidity is not easy like just reading a digital port or an analog port. We have some complexity in terms of the electronic protocol that we are using to communicate with the humidity sensor. So we are saying, I have the humidity sensor, is a custom sensor, and please call this function. So this is a function pointer, and true, saying this is a sensor. And the protocol, once you declare the components that you have inside your IoT edge device, you can ask, like you send to your edge device, give me your sensors reading. And so it will return to you a JSON, or you can choose a JSON or a very flat text with all the values, all the sensor values. And so you can parse this JSON in your preferred platform, like JavaScript, Node-RED, or anything else. So this is the way we relate the JSON result and the declaration we did in our edge device. And so here we have the edge device, the JSON messages running on MQTT and the REST passing to the gateway. And we have MQTT and REST, Android consuming, JavaScript consumers, and you could write your client using your preferred programming language, Python, C#, Java. So today, the first demo we are going to use is our edge devices. Let me put the battery here. And we are going to use the IoT surfing service, and we are going to use a MQTT client called MQTT FX. And this is a very nice tool, client for JavaFX, for MQTT, that James just wrote in JavaFX. He's a great guy doing a great project. He's the best MQTT client you can download in the internet. And fortunately, it was written in Java and JavaFX. Very good case for that. And thanks, James, for doing this nice work. So let me show you here. I am already running the gateway, the IoT surfing service here. So just what I'm doing, I will stop the gateway, clean the message, and start it again. So it's looking for Arduinos plugged in my computer. So it's trying to communicate with a COM port that is not an Arduino port. And finally, it found the COM5. It said surfboard 1 plugged into surfing IoT. And now you can see that it's reading the data from the sensors and receiving the JSON and sending the JSON message to the MQTT. And it's also listening to an MQTT queue, so I could receive the data from the sensors and also send, ask for the device to make some action. So let's show it. I'm going to connect this guy to... I am using here as broker. I am using the IoT.eclipse.org. in this port number. This is an open MQTT broker. Anyone can use. You don't need to even create kind of account. You just go there and use that. So it's very nice for demonstrations. And let's connect. And let's subscribe to the surfboard one. Subscribe, and I'm going to start to receive JSON messages here. Here we go. So I have here all the data in JSON, very easy to read. And the good stuff is that I could have like thousands of subscribers. And I don't need to take care of how each subscriber will receive that message. So it's very nice, very easy to play with. And I will show how to consume the data later. Now let's do something here. Let's say I want the surfboard one to turn on the green light. So publish, the green light is on here, and I want to turn off the green light. Publish. I want all boards connected in my system to turn on the green light. Publish. So both turn on the green light. So I could manage thousands of devices at the same time. And now I'm going to turn off the green light. Turn off very fast. From here to the IoT cloud system, and so our edge device. So it's amazing. And let's make some noise. Speaker 1. So very fast, they are receiving the message at the same time. Look at that. So impressive how fast it is.
So just a fast recap. This board, it's being connected to the internet through the USB cable, and then accesses the gateway that is running on the laptop. This board is connected to Zigbee to the wood laptop. Laptop has Wi-Fi.
Yeah, that's so they are both subscribing the same MQTT queue, and they are both publishing the data in the same MQTT queue. So that's it. So now it's all about having fun, because now I encapsulate everything using MQTT and JSON, so I can consume in different ways. So the IoT surfing service is a very simple Java software with many years of research, even being simple. Simple in terms of I didn't use lambdas, I didn't use frameworks, I did a very small and fast gateway. So here is a piece of code of our gateway. It's all about creating small services, following the concept of microservices. I'm not the big specialist in microservices, but this is the idea of our microservice extends MQTT controller. With that, I can say that this class, I'm going to make a configuration file, and I'm going to say the name of the class, the interval, if I want to have some process each 5 seconds or something, I could put the interval, enable true, and since it is a service that extends MQTT controller, I'm saying which kind of message, which kind of queue I'm going to subscribe, and this service will process this message. Basically, I will send to this service the name of a component, and it will tell me, it will speak the value of the sensor in my laptop. So in just a few lines of code. So let's show you here our framework. So it's all about having many different types of sensor services. Administration, audio, camera, FTP, JSON, MQTT, persistence with MongoDB, Raspberry Pi integration, REST, and this is the sample that I was showing. So very, very simple guy. to receive an MQTT message and tell me the value. So let me show you here. So now I'm going to say global code / audio and the name of the sensor, humidity. Humidity value is 31.00. So you can play with that, like you can play with your computer and you can start communicating in a very human way with your computer. So today we are going to use as eyes the Intel RealSense. Ears we are going to use Android, Tasker, and AutoVoice, and the nose for the alcohol sensor, and for the mouth we are going to use eSpeak. So eSpeak is this software that is running in my laptop. It's an open source for Windows, Mac, and Linux with different languages, and we are doing the integration using shell commands to call the eSpeak. We don't have any kind of Java API, native API for doing that. So I really recommend to use eSpeak as text-to-speech. So I did the demonstration showing that I can type the name of the sensor. For voice recognition, we are using Android voice recognition, which is very, very good and powerful. I like very much the Tasker, which is a paid application that you can automatize your cell phone in a very different ways. So I used to say, if I receive this voice recognition, then do that. And I'm using MQTT plugin for Tasker. The plugins, the AutoVoice plugin and the MQTT, they are free. So let me show you here. This demo sometimes is not that easy to work. I really depend on the internet. So I'm going to say temperature, and my computer will answer with the temperature value. Temperature. Temperature. Some time. So the other thing I can do, I have the relay here. Now I'm going just to click here and ask to turn on the lamp. So turn on the lamp and turn off the lamp. So it's really IoT stuff, you know. I'm really controlling the things using my cell phone. You can wake up in your bed and say temperature, distant to your house, saying the temperature, and turn on the light. So this is really big reality.
You can just wake up and say coffee.
Coffee.
That's useful.
So I think that this is the best part of our presentation. Intel RealSense, we are Intel partners, and we can recognize hands, faces, environment, speech, and it's very nice camera. This is a $100 camera. This camera supposed to replace the front camera from your tablet, from your notebook in the next 4 years. So think that in 4 years, all the computers will have cameras that can recognize your expression. Like if you are this way, write an email, it can say, no, I will not send the email. This guy is too nervous to write an email. You can make this kind of interactions. No. So here is though, you can recognize many points in your hand. So this is, here start being different from the Kinect perspective, because it's for low distance, small distance. Kinect, you can be like meters distance, and this camera is 1 meter max. But in other hand, you can have many points in your hand and really recognize gestures with your hand moving and things like that. And the face, the same. You can shake your head. You can recognize your expression and things like that. You have the SDK for RealSense. You have support for C#, Unity, Java, and processing, which is a very nice tool for graphical environment. And we have here a very fast demonstration because we are running out of time. I have here a very simple sample, I like this. And hence, I'm going to run this file here. It's JavaFX integration, and now I have the camera here, and I can move like this, I can move like this. So very nice, just a few lines of code, and very good. What we are going to do now is to use the camera integrated with MQTT and try to control our stuff using gestures and emotion expressions. So I have this nice client for doing that. Let's see how does it work. I'm going to say, I'm going to use this broker, and this is the queue that I'm going to subscribe. And what I'm going to show here first is that if I open my hand, it will start to turn on the speaker. If I close my hand, it stops. So let's see that. The V sign is to exit. Okay. And now, what about turning on and turning off a lamp using your smile? Let's see that. So you can integrate anything with MQTT. Oops, no, it stopped.
So the importance of the gateway is exactly to be translating all these different kind of message protocols, interfaces on, and putting all that to the same protocol like MQTT. So you are gathering everything, putting it together in the way that developers can work with the data.
And the last demo to finish here, we have the alcohol sensor. And what I'm going to do is to consume the message. Now I'm going to use the Node-RED. The Node-RED is a very nice software that you can consume MQTT messages this way. So I have here the surfboard one, and what I'm doing here, I am parsing the JSON data and grabbing the alcohol sensor. So I can see here in my debug window, here is the message going to the debug. So I have 300 in the alcohol sensor. I have this switch. If the alcohol sensor is more than 900, I'm going to set up a message, alcohol detected in ta-da-na-na-na-na, and I'm going to tweet this message if the alcohol is more than 900. So let's open the Twitter. So here we are in my Twitter account to replace the beer, because it's too early to drink beers at this stage. I'm going to use the Listerine. That's a real proof that it has a lot of alcohol here, and you can get in trouble with the police. So I'm going to do this. I'm going to put here the Listerine. So I'm making my board to get drunk. And so let's wait for the Twitter message. Here we go. Very fast. IoT software, alcohol detected. So Node-RED is an amazing tool for people that are non-developers and they want to consume IoT data and make some logic with input, output, switches, and things like that. It's a Node-RED, it's a Node.js software written by IBM. And you also could do it using JavaScript. You have a Pahu API for JavaScript. It's very easy to make a breathalyzer using JavaScript. The code would be something like this. So you could make an alert in your website, or you can change your website color based on the temperature. Like if it's hot, you can use a cold color. If it's cold, you can use a hot color. If it's snowing, you can change your behavior in your website based on sensors, which brings a lot of like integrating CSS with sensor data would be nice. So our GitHub, you have all the code in our GitHub. This Sanger is my personal, and Surfboard is the one that we are putting out this surfboard-related framework code in a more organized way. So with that, I would like to say thanks for everybody in the audience. Thanks to DevoxxMA Morocco. Okay, someone want to make any question? We will be here a little bit more. Okay, one question?
No, so thank you for the presentation. So my question is about the security authentication between the cloud and the device Raspberry or other devices. So
Yes.
there are session managed or there are token managed or automate the communication between the MQTT and the device.
Yeah, you can have a security layer. MQTT is very inexpensive protocol in terms of how much it will consume from your network and how much it will consume in terms of power. But you can add like certificates and keys to make the communication between the edge device and broker a secure communication. No problem with that. You have many options actually. You could make... Yes. You can do HTTPS over MQTT. If you are, like you already have the knowledge working with HTTPS and SSL, you can do over many different ways to do that. Okay, so HTTPS would be the most common way to do that, but the problem is that all the benefits that you have in the MQTT about being small and fast and everything, the more security you are adding, the heavy it will be, you know. But you can do many different ways. So it's a 15 years protocol, MQTT, and you can actually move from the broker, the public broker, and you can contract very nice brokers in the internet, in the cloud. So, and those brokers, they have many types of security service. So don't be afraid. You can prototype using raw data and go into production. You can make certificates and put SSL and make everything more secure. You know.
Any other question?
In the last Google I/O event, they have introduced two new standards for hardware layer and communication layer. Two products they called Brio and Weave. I want to know your what do you think about those two?
Is one more standard coming to the industry. You know, Google is big enough to push a standard, but I think that MQTT is 15 years old, and Google itself, they don't know anything about Internet of Things. They know about search engine and everything, so they bought this company, and they are trying to bring that to the Google. So this team, they have really good guys there.
It's
but
not the first acquisition, right?
They are
several
acquisitions. But the problem is having something based on Android. For me, it seems like heavy. Android, for me, heavy. Like, is too heavy. They are trying to make Android lighter with different types of profile. Android for cars, Android for this, Android for that. But sometimes we just need something that you don't have operational system. And the people like more the open source boards than the closed one. So since it's Google, I will not say that they will fail, but I don't know if they will need to put a lot of effort to make it happen in a very nice way and everything. So the way they do that is like you go to Google I/O and everybody win a board, and so that's an easy way to push a technology, not the people buying the board itself, and etc. So I think that they have a chance, but they will compete with at least other 20 different players that they are already in the road in the last 5, 10, 15 years. But I'm looking forward. For sure, I will buy it, I will study it, and I hope that next year I have some Brilio device, and I hope to support Brilio protocol in our gateway. And the gateways, they will need to support all the IoT protocols, and there are many protocols coming. Brilio is just one more. Okay, so we will be around for lunch if you want to talk with us, to have our business card, to know a little bit more about our code. Feel free to keep in touch. Thanks again for coming.